Everyone, my name is Muhammad Adlan Faris bin Nur Azizan. How are you today? I hope all of you are in good health because today we are going to learn an interesting topic, which is nuclear energy in 15 minutes. Are you ready? Let's start our class now. Okay, our class today are still in chapter 6, which is nuclear physics, with subtopic nuclear energy. We are going to highlight two learning outcomes. So, at the end of this video, you will be able to communicate about nuclear reactions, which are nuclear fission and nuclear fusion, as well as describe the relationship between energy release during nuclear reaction and mass defect. The equation we are going to see is E equal to mc squared. Before that, let us recall what we have learned before this. Do you still remember what is radioactive decay? Radioactive decay is a process in which an unstable nucleus becomes more stable by emitting radioactive radiation. Good, if you still remember. Next, can you give me an example of radioactive decay? There are three examples of radioactive decay, such as alpha particle, beta particle, and gamma ray. Alright, I want to ask you a question. Can you see the picture? It is the sun. So, how does the sun provide light and heat energy to the earth since million years ago? I want you to keep wondering because we are going to learn this topic that relate with these questions. Are you okay right now? Hopefully all of you are okay because I want to get your fully attention right now. We want to learn about nuclear energy. Let's go the definition of nuclear energy first. Nuclear energy is known as atomic energy released during nuclear reaction, such as radioactive decay, nuclear fusion, and nuclear fission. Nuclear fission and nuclear fusion are two nuclear reactions that produce nuclear energy. We want to focus on nuclear fission and nuclear fusion after this. Besides, there is a loss of mass known as mass defect occurs during nuclear reactions. Do you know why? I will explain to you after this. Physics is fun, right? Okay, now we are going to learn about nuclear fission. What is nuclear fission? Nuclear fission is nuclear reaction when a heavy nucleus splits into two or more lighter nuclei while releasing a large amount of energy. Based on the definition given, have you ever wondered how nuclear fission works? Let me explain to you. First, there will be a uranium-235 and a neutron. A uranium-235 nucleus is bombarded by a neutron, then it will produce an unstable uranium-236. Remember, nucleus need to be in stable state. Thus, a barium-141 nucleus, a krypton-92 nucleus, and 3 neutron are produced. In addition, energy is also released. There is an equation below. Can you imagine how it works? Let me show you a video to help you understand better about nuclear fission. Is it clear for now? Actually, we have done for nuclear fission. Alright, now we move on to nuclear fusion. Please don't get confused between nuclear fission and nuclear fusion. So, what is nuclear fusion? Nuclear fusion is a reaction in which small and light nuclei fuse to form a heavier while releasing a large amount of energy. There is a condition where the nuclear fusion takes place. These nuclear reactions happens under extremely high temperature and pressure. Thus, this reaction is not possible everywhere. What you can see in the picture, there is 2 small and light nuclei, right? Based on the picture and equation given, nuclear fusion between deuterium and tritium occurs to form a heavier helium nucleus. Energy and 1 neutron is also released. So, there is difference between nuclear fission and nuclear fusion, right? Let's watch a video that I have prepared for you. This video is about nuclear fusion animated with 3D program. Let's enjoy the video. Let's focus on the relationship between energy released during nuclear reaction and mass defect. Firstly, we are going to use atomic mass unit, or we can call it AMU, as the measurement of the mass of an atom. Can you see the atom? Do you have any idea how much an atom weighs? The mass of an atom is too small and difficult to measure using units. This is the challenge we are going to face, but every problem must have solutions. The solutions for this problem is we will use isotope carbon-12 as reference because carbon can be found in many compounds found on the earth. In a nuclear reaction or radioactive decay, the total mass of the decay products is always less than the total mass of the radioactive nucleus. This loss of mass is known as mass defect. Based on the picture given, we can calculate the mass defect. How? Let me show you. Firstly, we calculate the total mass before fission. The total mass before fission is 236.05259 atomic mass unit. Next, we calculate the total mass after fission. So, the total mass after fission is 235.86653 atomic mass unit. Lastly, total mass before fission minus total mass after fission to get the mass defect. So, based on the example given, the mass defect is 0.18606 atomic mass unit. Is it easy, right? The relationship between the energy release during nuclear reaction and the mass defect can be summarized by the following equation, which is E equal to mc squared, where E is for total energy release, m is for mass defect, and c is for speed of light in vacuum. Based on the knowledge of atomic mass unit and the equation E equal to mc squared, we can calculate the nuclear energy produced from radioactive decay processes and nuclear reaction. We will continue this on our next class. Okay, class, do you remember the question that I have asked you earlier? The question states that how does the sun provide light and heat energy to the earth since million years ago? So, what is the answer? The answer for this question is hydrogen nuclear fusion occurs in the core of the sun under very high pressure. In this nuclear reaction, two hydrogen nuclei fuse to form helium nucleus and release nuclear energy. This energy is radiated to the surface of the sun in the form of light and heat energy. Finally, the conclusion for the lesson are: how come there is no conclusion? Well, I think it will be better if you give the conclusion based on what you have watched in this video. Alright, so there are some questions that I have prepared for you to check your understanding. First, what is nuclear energy? In a nuclear reactor, atoms of uranium are forced to... Please fill in the blank. For the third question, where does nuclear fusion happen? And last question is, what do nuclear fission and fusion have in common? So, in the next class, I want to know your answer to these questions. With that, I end my presentation and thank you for watching. Have a nice day, everyone. Bye bye.